Everybody, it is 10 a.m. where I live. There's probably something different where you live. This is Nick McPhee. This is Unhindered by Coding. Hello, Azitsu. Wonderful to see you, as always. And we'll be here for 2 hours, probably not programming in any programming language. So currently working on trying to create some slightly less bad READMEs. The README on the unhindered-ec project was very short and largely incorrect, and had just never been dealt with. And so we're trying to fix that and tidy up some of the README stuff. And we started this last week, and we will continue it today. And I suspect that will take the bulk, if not the entirety, of the 2 hours. But we'll see how that goes. Okay, so where did we leave off? So we had, let's actually go here. So we had sketched at least a start to a README for the overall project, where we described sort of what the project was, and then we had laid out the project structure. So we've got the three packages, main packages, EC Core, which has sort of the low-level concepts like genome and individual, and there are some issues there. We will have to deal with those someday. EC Linear, which has some confusing specializations for linear genomes, and there's some work that definitely needs to be done there as well. And then Push, which is the most work in progress-y part, which is a little confused because it, as Izitsu has pointed out on a number of occasions, conflates the interpreter and the evolutionary system. So there really probably ought to be a Push and a Push GP or something like that, to clarify the distinction between them, and maybe even Push could come completely out of this, although I'm not sure how much use it has outside of this space. So, there are also a couple of macro packages that provide support, but you would typically not use them directly. And then there's an empty aspiration and goals section that we need to work on, and an empty how to get started section, which we need to work on, and a license and a contribution. And we had started at the end of the stream last time. We'd come over to EC Core, and it, I think, just begun doing a little work here. And so we have this to fill in. We have the EC Linear and the Push READMEs to deal with. Hello, Eustace. How you doing? Wonderful to see you. So yeah, we've got these three READMEs to build out at a minimum, and we have these dangly bits, the aspiration goals, and how to get started. Eustace, do you have thoughts on which direction you would like to see us head first in this list of things that need to be done? You would like to do the packages first, and I think that's where we left off last time, so that seems entirely reasonable. Okay, so we've got, we had started, I think, on EC Core. It looked to me like I made some changes there that hadn't been committed. And apologies, I'm all of a sudden very froggy. Excuse me. So this crate is part of the unhindered-ec project. This crate provides evolutionary computation functionality, so core evolutionary computation such as interfaces for genome, individual population generation. It also includes support for operators, which encapsulate logic that maps from one type to another. And so I think we had just gotten here, and we were listing some operators and their mappings, and so I think this is where we left off. So why don't we continue to work on that? Sorry about that. which maps from one genome to a presumably modified genome via some kind of mutation operator. And a recombinator which maps from one or more genomes to a child genome via some kind of recombination operator like uniform crossover. And okay, I'm going to close this so it's not in the way. So what else did we have? So EC core source operator. What else did we have in operator? Mutator. Oh, selectors. Selector, which maps from a population of individuals to a single selected individual. So that's selecting individuals to be parents, typically. And come here. So, well, that's what's, go away. Here we go. So, mutator, recombinator, selector, scorer. So the other, probably worth mentioning that there's composables, tools for composing operators, such as and then. Probably could just say that. So I think that gets, oh, maybe, yeah. I think that's probably enough on the operators. Yeah, so let's see if we close that. We've mentioned individual. Oh, child maker. Child maker is kind of a mess, actually. So it really ought to be a genome to individual operator, and it's not. And so that probably needs to be fixed. Good job. Cookies are a wonderful thing. So I don't know. Child maker ought to be an operator. It isn't. It's sort of floating around, and it's kind of weird. Yeah, so I mean, I think you're right, but I think there's a chicken and an egg, right? If you don't write any document, if you wait until everything's completely done before you write any documentation, then you tend to not write any documentation ever, because nothing's ever completely done. I mean, even APIs, especially on a project where there's not a lot of people using it, APIs tend to wander around. But if you over document, you're documenting things that aren't really there. Yeah, I'm pretty sure it does. I think that if we look at, for example, if we look at push examples, I feel like there is the child maker gets used here. Or not. Maybe I'm up a tree. Does ChildMaker actually get used? That's a great question. ChildMaker mod. Does this ever get used? Find all references. Apparently not. Yeah, so as I agree. Like a README in particular, the farther the documentation is from the code in terms of like files and distance in the file structure and the text within a file, the more likely things are to get out of whack. And so that is risky. So I think you're right. I think ChildMaker may not actually be used anymore. It looks like it's so I think that let's just not even mention ChildMaker in the README, because I think that is just going to be confusing and it's unclear that it actually is being used anymore. So let's just ignore that. So generation, which is kind of a mess, genome, population. And this is part of like, I don't think I'd want to say much about generation other than just list it, because I think it's probably not the design we want. Saying that there is one, I think would help. It would make sense to people who are used to evolutionary computation, because they would expect maybe some kind of generation type, and this would tell them where it is, and without going into details. And for people who are not familiar with evolutionary computation, it would be a sign that, oh, there's this notion of a generation, and that might be a useful thing. So, but we don't need to say anything. Yeah, so I tried actually to say kind of what a mutator does a little bit. Do we think that that's not, would you like more, I guess, than that? Or is that sufficient? I think would be the question. Hello, Wagafa. Oh. When you say, yeah, I think this is very little, I'm not sure how to interpret that. Like, not insufficient? Like we'd want to say more about these things? Or it's not much and that's probably fine because we don't want, oh, you think we should say more. Okay. Okay. Scores are used to in selection oh, I see what you're saying. So some kind of like flow chart that indicates kind of what's happening. Yeah, okay. So actually, let me add, well, maybe we focus. So a question quick. Do we think we want sort of an Excalidraw thing? Or do we want, oh, that won't work here. I don't think GitHub supports something like Mermaid. So I was thinking in Obsidian, you could use something like Mermaid to make a drawing like that, but I don't think that's going to be an option. Oh, it does support Mermaid. Oh, look at that. Copy URL. So do we think something like Mermaid would make more sense than, oh, look at that. Look at that. Yeah. Right. So if we have Mermaid in the text as just markdown, then when we get to crates.io or lib.rs, would does crates.io support Mermaid? Oh, crates.io does support Mermaid. So say the AI overview. Oh, actually, no. I think it's saying a different thing. It's saying there are crates for rendering Mermaid in documentation, but it doesn't mean that crates itself will do it. So I'm not convinced that's going to be a thing. Yeah, I think that's exactly what it's confused. I think the AI is befuddled. Wonder what that says. That doesn't even try to provide. Okay, I'll let you test that because that's an interesting possibility. While you're testing, I will add a little text. And actually, I think, thinking about it, I think actually having selector first. Typically how parents are, oops, I'm getting very long here, are selected preferring individuals with better scores. Yeah, I think you're probably right that it's not going to work. But I figure, if Usis wants to give it a shot, we'll find out soon enough. And then we can just do Excalidraw instead, which would work. I mean, no issues there. So actually, I decided I want... it's kind of a mutual recursion between selector and score, and I'm trying to figure out which order I want to put them in. So maybe I go back to having score first. The scores are used to copy URL. Oh, it did work. Well, that's cool. Do we... Is this going to be visible on lib.rs? Do we know if lib.rs deals with this in a useful way? Lib.rs. Does it show up here? Oh, there we are. And it doesn't look like maybe this one's updated yet. Yeah. Because this sort of ends at this point here. I don't know what the timeline line on getting these things to update is. Well, I'll make some additional notes here, and then we can come back in a second. But so I guess then that still doesn't inherently answer the question: do we prefer Mermaid to a actual graphic, or not? I mean, Mermaid has the advantage that it's text and it'll be in the version control, and it can be modified by simply editing the document. But it requires that one understands Mermaid syntax, and it's definitely not WYSIWYG in the way that sort of an Excalidraw diagram would be. And it might be harder. Actually, I have to think about this a little bit. Might be harder to add annotations. I think you can add annotations in Mermaid, but I think might be more difficult to like figure out where to place them and stuff. And Eustace says you can embed Excalidraw metadata into the SVG and just open the SVG with Excalidraw again. Really? Oh, okay. So is the suggestion here to go with Excalidraw? And if I share this, I think that would be what I want. Copy the link and put the link in the chat. Oh, different color schemes. That's an interesting question. So I think Excalidraw is going to have, it's just going to be its color theme. I mean, because it's just going to be an image, right? And it's not going to change. I assume you mean like light mode versus dark mode. And Mermaid would presumably switch back and forth in a way that Excalidraw probably won't. So if we do it in dark mode like this, then and somebody's viewing it in light mode, you'll just have a big diagram with a black background, which is not the end of the world, to be honest with you. But yeah, it wouldn't fit in quite as nicely as it would with something like Mermaid. I think it would be more integrated into the color scheme. Yeah, that I did notice that these arrows are almost invisible here in Mermaid. So that actually might be an argument against Mermaid, is that the arrows here are very hard to see. Now we might be able to change the colors. Let's see if I reload this. Do we have? No, I don't think anything's happened here yet. Oh, I've got all this. Oh, gee whiz. I really wanted a new diagram, didn't I? Although I guess I don't care about any of this, so we could just clear this. I assume there's like a wipe everything and start over option somewhere. Maybe not. Maybe I have to select everything. Select all. Boom. Okay. There we go. So, okay, blew it up. So we want something like a population. Oops, come on. Hello, Earth to Moon, come in. Pop. Hello. There's actually stuff happening up there. I should actually stop doing what I'm doing. Oh, look at that. You're doing stuff. Cool. Now, do we say something? Is there something in EC core about population is just a simple trait, and there's nothing specific about how that gets, what implementations exist of it. So where is that actually implemented? Who implements we implement population for T, where T is something that's iteratable over individuals. And since all we offer is empty and size, so population really does very little here. Who refers to population? Generation has a population in it. Yeah, so P is of type population, and let's look at serial next because that'll be easier. We make a new population out of the old population. Okay. And then somewhere, I think vector implements population, or linear implements population. So that's a little awkward. Let's go back to here. So you generate initial population, you score the population. Okay. So your orangey, ready diamonds are things that are used to generate something. And so a generator generates the initial population. And that's, and so we get a population, we score the population using a scorer. That gives us test results. Now, was there a reason you used an oval? Gotcha. Thank you. I was just asking that question and you'd already answered it. So diamonds are traits and ovals are types. Actually, I think it's not an unreasonable idea. And so then we get test results. And then, so here on this select individuals, I would put a selector, which is also a, what is selector? Operator selector, is that a trait, I assume? Yeah, it has to be, because there are all these different implementations of it. Yeah, so a trait selector. Yeah, so I would have something like that. And yeah, and then have mutators and recombinators. And then we're back to a new population. Yeah, I think that looks totally lovely. I think that's not an unreasonable I think you want probably a curved thing there, yeah. And then we got to figure out how to get that to happen. Zoom out. Yeah. Oh. There we go. Yeah. I think that's very nice. So is generator a thing in our world? Generators make stuff. And yeah, so do we have that as a concept that's captured in the code? I don't think it. I thought there was a yeah. Oh, is it in the distribution stuff? So I don't think we have. Actually, if we look at, let's go to push again, because those are always. If we look at how we make individuals, so here, we have a gene generator, which is this distribution of things and is of type gene generator. And then we turn that into a collection generator. And then we attach scoring. So the collection generator makes collections of genes, basically sequences of genes. Then we score those. And that is of type individual generator. And then we do into collection. That makes a vector of individuals. So that's a generator of individual generators. So we do have things. So generator is here in collection. That is not where I would have expected it to be. And Azitsu says, my code still has a separate generator trait. And I still think that makes more sense than using distribution. So a generator, information for generating a collection of random elements. Size indicates how many elements to generate. Element generator is used to generate individual elements. So this says collection generator. I think that's probably just wrong. It should just be generator. And then we have convert to collection generator, which is a different thing. And then we implement distribution for generator, so you can sample the distribution, and that actually gives us an individual. So there are generator things. They may not be named the best or in the right place, but they do exist. Okay, so, oops, actually, I'm back over. Let me zoom in a little bit so I can read the text. Generate initial population. So we have a distribution, and these are various implementations of distribution. And then that makes a population of things. We score the population using a score. That gives us test results. We select individuals from the population using a selector. And then, so you're suggesting that we've got multiple mutators, which are then feeding into a single recombinator, is the way I'm reading this. And then that gives us back a new population. So I think we probably want a blue diamond, on that edge. Yeah, just that. So this is a little awkward because really you could have no mutators and just recombinators. You could have no recombinators and just mutators. You could mutate, feed the result of mutation into recombination, and then mutate the result of that. I mean, there's like kind of an infinite collection of things. What might be simpler is instead of splitting out mutation and recombination in the diagram, to have a single box, which is mutate and or recombinate, and with mutator and recombinator as little diamonds there, that then creates the new population, so that we're not implying anything about how many of these there are. Well, I was actually thinking, okay, I see what you're saying. Yeah. And this would be a not an uncommon example. So then you would have arrows presumably going from the mutate individuals to the top of the recombinator, I'm assuming. And that would work. I mean, I think this could be totally reasonable as just a sketch of what's going on. Yeah, that's probably true. And then probably move the whole selector thing up some so that it doesn't interfere with that line. Yeah. Yeah. Yeah, I think that's better. And then move that guy down and a little lower, yeah. Sure. And so then there'd be arrows going from like here to here. Yeah, your arrows, not my arrows. Those things. Yeah, I think that would work. It is a way of doing it, and it's not an uncommon way of doing it. It's not actually what we're doing in most of our examples, because most of our examples just use, on the push side, just use UMAD and don't actually do any recombination. But, recombination is pretty common. Do we want these arrows to like actually, yeah, that thing, perhaps. Do, do, do. And let me zoom in on this. Yeah, I think that's totally reasonable as a disclaimer. I'm good with that. I don't think that's a bad thing. Um, oops, In fact, I guess there's a question. I think it makes sense for this to be an EC core, but I wonder if this same diagram wouldn't also make sense in the top level README. Just as a, for if somebody comes to this and has no idea what they're getting into, this would provide a sense of what all this does, and maybe a variant in push potentially. I mean, yeah, you could have a variant in EC linear where it, and have specific EC linear types or push types depending on where you are. That would be entirely plausible. I mean, this is one of these places where Zitsu, yeah, there are a couple of places where, I mean, you score the individuals in a population, and here recombination generates a single individual, and then this magically turns into a population. So there's a couple of places where we're being a little loose about transitioning between populations and individuals in a diagram like this. And short of having like a loop thing that says, for each individual do blah, yes, a didactic reduction. I don't know that, because I think you would, like, if you were talking to EC people and you said, we'll score the population now, they would know what you would mean. That would be, that really means we're going to score every individual in the population. And so I think this would work for them. Now, we don't necessarily want EC people to be our only audience. And if it doesn't, if there's something here that we think would confuse non-EC people that come to this, yeah, I mean, and that's, at some level, that's what the examples in the code are for. But we could have descriptions in the packages, like, okay, we have, let's make sure I'm in the right place. Like if we go to, so EC Core doesn't have any examples, but EC Linear does. So we've got a couple of examples. We could, in the README for EC Linear, describe these examples or have linked descriptions of these examples that would provide more detail. I mean, but this is also where Izitsu's worry about too much detail here, then this has to be rewritten if we make changes. If we keep this fairly abstract, then it's less likely to have to be modified as we make other changes. So I am kind of inclined to keep this reasonably high level because it reduces the likelihood that we have to come back and fiddle it every 10 seconds because we're like, oh, we finally got around to fixing this problem, and now the diagram doesn't work. So yeah, I think that this level of abstraction is pretty reasonable. I think that's actually a nice diagram. Totally reasonable start. Now the question is, do we want to, because there's a couple of options here. We could, for the moment, just link to this diagram. Can we embed? Share. Can I? Eustace actually did all the work, and I own this. Can I sort of export image? Yeah, I was like wondering if I could just have a link that would, and we could have a link to this in the, but then we have to sort of re-export it every time, which seems be nice if you just sort of link to it, and then if you modified it here, it would modify what we get on the other end. Yeah, well, that's famous last words, I think. Okay, but we can do this. So this is, what do we want to call this? Evolutionary Computation Flowchart. SVG. Okay. And then that's going to have to get copied into the code. So the Excalidraw now, by exporting the scene, has all the details in the metadata, so we can re-export it, reopen it. Well, that's good. That's cool. Okay, so I want this to go here. Oh, no. What that back up. I want you. Hello. There we go. Stop it. Downloads. Here we go. I want you to drag to here. Hey, look at that. And then we ought to be able to add that to the README. And that's, is that not the right syntax? No, it's that. Come on. Oh, stop it. Wrong place. Go away. Oh, do a dot. There you go. Well done. Yes. Diagram of basic evolutionary computation process. Blah, blah, blah. And then if we go over here, does that do it? Hey, look at that. We have a diagram. Yes. That probably would make more sense, wouldn't it? And I forgot that there is? There it is. Yes, there is in images. It should totally go there. Thank you. And if I do that, did it up? No, it did not. So, images, that one, boom, bop, and come back over here, make sure it loads up. It does. Yay. Nice. Cool. Now, should the diagram be at the top of this page? Yeah, that's a good point. That if we include it in the main README, then it's not sort of tied to a package, which I think is a good plan. So do we think this goes at the top after we say some things? So you're thinking like here, maybe. Oops. But maybe with some more text above it. So like, not sure structure's the right, I'm not sure I like these words, but the diagram below illustrates an example of a common evolutionary process. We start by generating a random initial population of individual. I mean, actually, I could be turning these into traits or backticks as an indication that these are types. These individuals, are then scored. Well, I'm not going to repeat all of it, but I do think saying in words, I mean, it's one of these things that there are people that like pictures and there are people that like words. And I'm not providing nearly as much detail in the text as is in the picture. And what we can scores are used to select individuals, the best individuals to be used as parents. Those parent individuals are modified using mutation and recombination operators to form new child individuals, which to create here, and which form the new population. To create a new population. Yeah, to form a new population made up of child individuals. To form a new population made up of child individuals. Yeah, okay, I like that. Bum, 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 ba-dum, bum. So then if we have that, sorry for the scrolling, we could say that this crate provides core evolution computation functionality, such as interfaces for these things. It also includes support for operators with encapsulate logic that maps from one type to another. This includes score, selector, mutator, recombinator, and tools for composing operators such as and then. You would prefer the text below the diagram. It would be the diagram above. Oh, I see. I see what you're saying. So you would do this, and then it would be the diagram below. I see. Yeah, okay. I can buy that. Oh, interesting. Make it wider, and just the image got wider. So actually, it reads a little better this way. Okay, cool. I think that's a win. I think that's an improvement over what we had. Do we... I was thinking it might make sense to say somewhere, see EC linear examples for simple examples of simple implementations. Oh yeah, sure, we could add this process repeats until with the new population, well, I think we'll just say repeats, until some exit condition is reached. For example, we have found an optimal score, or the maximum number of generations is reached. Etc. Yeah. I think that's reasonable. And then I guess we could say C the EC linear examples for implementations of simple bit string evolutionary processes. So do I really need probably don't need the word the there. C push examples. Push examples. For example, for implementations of push evolutionary processes using push GP. That should be bit string to evolve push programs. So do we think that's enough for this? Because I think, you know, acknowledging Zitsu's concern about too much detail is appropriate here. And this, I think, captures the key pieces. And then we could move on to another package. Let's see. Let's have a look at what you're up to. Aha. Oh, yeah. So you've got the termination condition. Yeah. Let me zoom that in. But that looks plausible. So instead of decide if last generation was reached, I think I would say maybe just terminate question mark. Yeah. And then we don't get into the weeds of what termination means in this context. Whoop. Yeah. And I like the, actually I like to do something with the final population statistics, reporting, whatever. I think that captures the fuzziness of it in a useful way without getting into the details. Would it mess up your little diamonds if it said new population and final population on these two diamonds? Or would that mess up the sizing of the diamonds? And actually, really, maybe the thing to say new population is this guy right here. Well, actually, probably both of those. If both of those said new population, and then this one said final population, that might be kind of nice. But I don't know how, I don't want to mess up the setup. Oh, and you got EC individual here, yeah. Oh, I see. Okay. I was thinking of putting them in the blue things. But yeah, they could live outside. That's a possibility. Right. Since they're meant, right. They're supposed to be types. Yeah. I got it. Yeah. I like read chat, please, in the diagram to tell me what to do. Yeah. So, sure, I think that's fine. And so I would need to re-export this again. And this is the challenge, of course, is every time there's a change here, we got to do this whole export thing, which is export image. Okay, everything's turned on. SVG. I want to be here, and I want to be. Oops, no, don't do that. Oh, come on. Why are you doing that? You weasel. Oh, hello. That totally didn't do what I wanted. Stop it. Go away. What if I do that? Oh, why are you... My Windows with my using my iPad as the second screen. I'm clearly like struggling to cope with basic issues. Desktop. No, that's not really what I wanted. I must have closed the thing that I wanted. I think that's my problem. Okay, downloads. Don't close this time. That would be a good thing. Let's see, I need to delete you, and I need to rename you so we don't end up with a bunch of funky names. And I need to copy you now over here. Boo-ba-doo-ba-doo-ba-doo-ba-doo. Yes, I want to replace. There we go. And there we go. And this does not have the changes. What did I do? Did I get the wrong thing? Help, help. What have I done? I must have... No, that's got the right thing. Does this just need to reload somehow? What if I need to save? Because it should be... This should be the right... Yeah, this has got the new notes on it. Just this hasn't sort of reloaded for some reason. That's weird. Oh, now I can't see the chat because I've gone off and done something silly that way. Find the chat again. Yeah, I'm guessing it's cached. This is the EC Core README to ants. Oh, and hello, C Films. I missed your arrival. Welcome to the stream. Always a pleasure to see you. I'm doing fine. I'm at my sister and her husband's house, and we're going to take my mother to the National Quilt Museum day after tomorrow in Paducah, Kentucky. And I'm helping my sister plant garden stuff. And yeah, it's good. Having a good time. So I assume this is just a reload issue, and I'm not going to worry about it. So come on. Hello. There we go. I'm going to close you. And okay. So should we move on to another README? And we can, I'll just leave this here for now, and we'll come back. I'll commit it when we get closer to the end. And so if we were going to do another README, actually I'll leave that open. EC Core, EC Linear would be the obvious next one. Okay, so basic tools for evolving linear structures such as bit strings. Yeah, that's probably true. Well, in this one, we have to be a little careful not to say too much here, because there is this weird business of I thought vector was in here. Is vector? Oh yeah, vector is in here. Yeah, so this whole vector bit string thing, I think bit string really ought to be vector or linear genome or something. So yeah, there are some issues here about what's going on, and we don't want to say too much about that. But we could say something about the tools that we provide, because I think that's useful to know. This includes a variety of mutation operators, such as UMAD. How did we actually capitalize that? UMAD, okay. UMAD, uniform mutation through addition and deletion. Oh, we probably ought to mention on the other one that the selection operators that we have implemented, because we did implement a lot of selection operators, and it's probably worth noting that, because those are not likely to have to change. With rate, which mutates an element with a given mutation rate. You go and with 1 over length. And I don't really need these parentheses. So actually this really, which adds and deletes elements I can just leave it like that maybe. A table with recombinator mutator types at the top. I don't know that we need that, because actually at the moment all of these work on fixed length, and the only one that is it true? Yes. No. All of these work on variable length, and UMAD is the only thing that doesn't work on fixed length, because it can change the length. So it probably, we need to mention that can change the length of the genome, and so can only be used with variable length linear genomes. I have not. Well, I use Google Docs a lot, because that's what my students and colleagues do a lot of their stuff in. But I actually write very little outside of Markdown anymore. And I mostly do it in either Obsidian or VS Code, to be honest with you. I don't write much that doesn't at least start life as Markdown anymore. And it's kind of weird how often I end up drafting things in Obsidian and then pasting them into other tools. Which mutates elements. So actually, I'm going to take this out. I'm going to put this down below, and we'll say something about which mutates elements with the mutation rate. Ooh. I can't do this here, right? 1 over, come on, 1 over L, where L is the length of the genome. Oh, that does work. Is that going to work in GitHub? I would love an apple, but I don't think there's an internet protocol for delivering apples over TCP yet. So, will this bit of math, will this actually work in GitHub? I honestly don't know. Maybe. It worked here in VS Code, which slightly surprised me, to be honest with you. So, okay. The UMAD mutation operator can change the length of genome and can only be used for variable length linear genomes. The other two mutation operators maintain the length of the genome and can be used with both fixed length and variable length genomes. Okay. We could actually just have a section here for mutation operators and combination operators and well, you could have a variable length system that mixed both, say, UMAD and with rate. So that sometimes you would use with rate and that would just keep it whatever length it had been. And other times you would use UMAD and that might change the length. So you could use those in a variable length setting, presumably in combination with some other tools that might change the length. That's what I was thinking. There is support for both fixed length and variable length linear genomes. And plushy genomes. Well, there are problem spaces where, fixed length, I mean, in a push program, it doesn't make any sense, but if you're doing a bit string thing and each bit corresponds to a single item in the problem space, then fixed length makes a lot of sense. So if you're doing, for example, the knapsack problem where every knapsack item has a single bit associated with it, yeah, C push crate. Yeah, it wouldn't make sense to have to say you were working with variable length genomes and only have fixed length operators. So, I mean, I guess I meant this to be they can be used in a variable length setting, but they would only make sense if you had some other tools in play. Like you could have a recombination operator that changes the length and still only use fixed length mutation operators. I mean, it just gets complicated, right? And then recombination operators, what we have? We have crossover. Crossover, is that a real thing or is that just a trait? That's just a trait. I say variety here, that's a little generous. A few mutation operators. I should say this crate. It's not clear what this is. Includes a few recombination operators based on the crossover trait. So MD is in a main. Oh, MD stands for Markdown, actually. And it's the primary document type used in a lot of systems these days. GitHub, for example, sort of groks Markdown. A lot of static site generators are built around Markdown. I mean, it has the advantage that it's not a binary file type or file format like, traditional proprietary things like Word, R, or PDF or something like that. Yeah, so Markdown that's the main thing I use these days. I do most of my writing in Markdown, probably 80+%, with the rest being email. And I mean, I even use Markdown in Google Docs because it supports Markdown stuff. And I find myself just using my Markdown tools in Google Docs and it interprets them. So how long will it take you to get from Germany to Japan? I'm curious. So I think Markdown is way less noisy than HTML. So like this header 2, right? This would be something like that. And notice that Markdown accepted the HTML. And if I wanted a list, I would have to do something like, let's say an unordered list. And And li frogs, li geese, li monkeys, right? So you'd have something like that, whereas in Markdown you would just say frogs, geese, and monkeys. And so it's a lot less noisy. Wow, that's very cool. That would be quite the trip. And then you would fly from Japan to the Americas somehow, get across the Americas, and then fly from there to Europe or Africa, I guess. So I don't know if that makes sense, C-films, but that's sort of a quick comparison. There's, if you Google Markdown, so the Markdown guide, actually the cheat sheet would have been maybe the more useful thing. So the Markdown guide gives you the basic pieces, and so you can do tables and stuff like that. And then there's GitHub Markdown, where they support that and have some additional special GitHub-y things, which are kind of cool. So it's pretty nice. And I have, kind of without really planning to or thinking about it, I found that I just sort of drift into Markdown almost entirely these days. So oh wow, okay. And so, but the plan was to go all the way around the world, I thought, right? So at some point you get to the end of Asia, Oceania, and then, okay, and then Australia, New Zealand, and then fly to Chile from there. And then are you just crossing South America and then jumping over to like Africa? Or are you coming up into North America and then going over to Europe? So recombination operators, what do we have? We have uniform and 2-point is all. Well, that's not very impressive. Uniform, which chooses elements from, I'm not saying this very well. Okay, you'll skip Africa. So up to Canada, and then from the East Coast to Portugal, and then from Portugal to Germany. Wow. And I assume you're going to have to jump over the big swamp in Central America, where it, like, basically you can't get across the isthmus there. Yeah, the Darien Gap. That's the thing I was thinking of. Yeah, no, that doesn't sound like that would be a good place to try to go on your own without an army, frankly. So, very cool. And I think, that's what most people do, is they ferry across the gap. So, well, that sounds like quite the adventure. From two parents, uniformly from two parents, and two-point XO, which chooses two random locations along the parent genomes and swaps sections. That's really a terrible description. I almost feel like, wow, 4 years. That is very impressive. I have certainly never done something like that. My sister and husband are currently planning. They've done some serious bike touring in North America. I don't know that they've ever done anything. I don't know if either one of them have ever done any serious biking outside of North America, but they've done some serious biking in North America, like crossing the Rockies and stuff like that. And they're going to drive out to Washington State to visit some friends and planning to do several days of cycling at different points along the way. And they're currently trying to find some cycling to do in the Rockies in either Idaho or Montana. So when do you decide to add a README to a repo? There is a school of thought that says it should be the first thing you add to a repo. If you're sort of serious about the repository, like you want to describe what it is your goal is up front, and then that README provides the sort of roadmap for how the project proceeds from there. I think that's very rarely done. I mean, but there are people that make the case. I usually don't do a README soon enough, and I usually don't spend enough time on them. So that's an issue. It's not something I'm great at. I think that most projects, but as Zitsu pointed out earlier in the stream today, there is a balancing act between documenting before you know what it is you're building. And if you write down a bunch of documentation that just doesn't line up with the code, that doesn't accomplish anything. And so you kind of want to get far enough that you know what it is you're building. But I think I tend to wait too long. Yeah. Well, good luck with the visas and the working and the skiing and the biking, and it sounds like a lot. So it sounds super cool. I loved the one time I've been to Japan for about 3 weeks. I had a really good time, and I would love to go back, but I don't know if and when that's going to happen, at least in the near future. So, so really that kind of needs a picture, but I don't know if that makes sense here. Ooh, wow. Yeah, I hadn't thought about the sort of the Russia-Iran thing. Whew. Yeah, you're going through a bunch of an interesting collection of countries. So how does the Japan thing end up? Do you end up in like Vietnam, Thailand, and then because you can't get to South Korea without going through China and North Korea, and that doesn't seem like a good plan. Yeah, that route doesn't work. No, that would be really not, Myanmar would not be a good choice. Well, and so you could argue, see films, that the website is the README in some ways. It also depends on, like, do you have any reason to have other people care about the repository. Like if you don't have any interest in anybody else caring about the repository, then you don't really need a README at all. But if you might want somebody like a potential employer to visit the repository and be like, oh, C-Film's a pretty organized together guy, then it might make sense to have a README that at least says a little bit about what you're doing and what your goals are. But, Turkey, Armenia, Iran, Turkmenistan, Uzbekistan, Tajikistan, Kyrgyzstan, Kazakhstan, China, Mongolia, China, South Korea, Japan. And then, so a ferry from China to South Korea, and then a ferry from South Korea to Japan. Wow. Yeah. That's a lot. That is a lot. Yeah, you get to go through all these places that used to be part of the Soviet Union along the bottom there. Interesting. Wow. Okay. So I don't know. I feel like the 2-point crossover really needs a diagram to make any sense. And the question is, do I make that diagram now, here, or do I not worry about it and try to press on? I mean, we could presumably diagram a number of these things. Iran, Pakistan, India, yeah. So I think that was the one I was thinking of as sort of the Thailand, Laos, Vietnam section. But yeah, with Myanmar being the mess that it is, that probably doesn't make a lot of sense. And once you get into India, it's kind of hard to get out of it because of the Himalayas without going through Myanmar. So, well, how exciting. So, Eustace, do you think that this needs a diagram here now? Or do we think that that just gets left and we deal with it later? I don't have a strong sense of that one way or the other. And what was I gonna, there was something I was going to do back in EC Core. What was that? This reminded me of something. But what was it? Don't remember now. Yeah, that's a pretty hard barrier. Well, we could do a diagram. Now, how do I make a new thing? How do I make a new thing? Is that library? No, that's their stuff. How do I make, I just want a new diagram because I don't want to mess with this diagram. This diagram's a good diagram. Leave it alone. Is that open? That doesn't seem like any fun. But that's really what I have to do? Huh. Well, I could close the session. So then reset the canvas. I expect that must nuke everything. Boom, boom. Okay, so I want 2-point crossover. So I want something like, and I want, And then I can duplicate that, right? Duplicate. So it's Command D, okay. Probably haven't spaced these very well, but you know, that's why we're in Excalidraw and not in something else. Scooch you over a little bit. Maybe scooch you over a little bit. Yeah, that'll do. And then I guess I need a couple more. One more. So 2 point. So we'll take all of this and we'll duplicate that. And this will be the other parent. So I guess we should say that. First parent. Oops, did not give myself enough room there. Duplicate that. Oops, no, come on. There we go. And this is second parent. Oh, I'm going to need all of this again. Duplicate. And child. Oops. So we're going to choose 2 random locations. So we're going to turn you into a hard line and maybe bolder and maybe even a color. Boink. And let's do this one. Solid line, bolder, and a different color. Boink. And, oh, invite, yeah. Live collaboration. Copy link. Come on. And let's bring you down a little bit. And so then actually you will also be solid, bold, green. And you will also be yellow, bold, solid. And then actually we probably want, oh, is that going to be an issue? Because, oh, hey, how did you do that? And are these individual boxes? Can they be colored individually? Oh, it's a library. Yeah, well, that's much better. Then we'll do that. Now, can I change the color? Oh, these aren't lines. So I'd have to put a line in, I think. That's my guess. So if I want, like, say, to put a line here and bold, but that works. Okay. And then I could put a line here and make that blue and bold. Yeah. And then we want a different color for 0, 1, and 6 through 9. Now, that hashing isn't very visible. In dark mode. That's better. Yeah, that's better. I expect this is a nightmare if you're colorblind. I have no idea if we've managed to do something reasonable for folks that are colorblind. Oh, and actually, okay, yeah, that'll be okay. We'll fix it. So then we'll have second parent. And what we've actually drawn is the child, not either of the parents, it turns out. We'll clean that up in a second. Child. So, oops. So actually we want all of one of them to be red and all of one of them to be blue. Yeah. Oh, and actually we could leave it like that. Sure. I was thinking of actually having the whole first parent be blue, but the having the black is probably fine, and that's okay. So that's cool. Nice. Oops. Yeah. So I think that's a reasonable. So that's 2-point crossover. We're going to choose two crossover points at random. Here we've chosen them between 1 and 2 and 5 and 6. And then you take the relevant segments from the two thing. Now you got this browse. Oh, that wasn't useful. That's going to end up all kinds of places. Where'd you get the sort of stick figure? And is there like a baby you could, or some child looking thing that you could get? Sure. We'll have traditionally gendered parents. The mother being on the old side. There we go. That'd work. Okay. So then we would export that. Well, I guess I should, before I export, do you have other things you were going to add? I guess we could probably label some things, couldn't we? Labeling might be good. Let's see, I want here and here. So these are crossover points. Crossover points. I guess I've got way too much fun and excitement there. Boop. Yeah, and then your dashed arrows, I think. And if I should probably actually say 2 crossover points. Yeah, randomly selected. So we say 2 randomly selected crossover points. And yeah, that thing. Yeah, that's nice. I like that. Oop. Yeah, I think that gets the point across nicely. I think might do that. But yeah, I think that does well. I like that. Should I export this, or do you have other things you wish to fiddle with? Export away. Okay. Export. Export image. Make sure all the things are turned on. SVG. Wait. Okay. I'm waiting. Yeah. Sure. That's better. Okay. Export again. Everything's turned on. SVG. Let's go. Okay. And now I did not close things, so I should be able to actually make this work without the chaos of before. Images. Okay, that's actually got the wrong name now, so that should be 2.2 crossover. Spelling. Crossover. SVG. Boop. As illustrated below. Bop, beep, boop. 2-point crossover. Let's see, illustration of 2-point crossover. Images. 2-point crossover. Bop. Boom. Boom. Nice. Cool. I like that. And then actually we could do something similar for the other operators, but not in the 7 minutes that we have left. Look at some fun things you added to the drawing. So this is all stuff that you can get from libraries? Wow. So, okay, like when I go to library, I get Zippo. So I presumably have to browse libraries and find things. So software architecture gives you software architecture things. And, so here's the people, your stick figures. Where did you get the grid from? With the 0 through 9 and the boxes? Because that's the kind of thing that, scroll a bit more. Google icons, more icons. Oh, was it this? Algorithms, data structures? Yep, okay. So if I add that, yes. Ooh, weird. It rolled me back. That's very strange. I wonder why that happened. And so you were able to do, it's probably like this guy right here. Look at that. Yeah. Hot diggity. Oh, it went to my personal canvas, not the shared one. Oh, and this one has with the numbers on. Nice. That is very cool. Very cool. That's very nifty. I had never actually used library stuff before, so that's kind of slick. And obviously it made getting here a lot easier and gave us some fancy stuff. So that's pretty slick. I like that. Okay, so it is 11:56. Wow. Sketch out an entire interface. Yeah, that is very nifty. You can really go crazy with this stuff. Because obviously they've got a lot of things. Huh. Wow, yeah, they do have a lot of things. That's a big scrolly bit. Piping and instrumentation diagram, in case you need to do piping and instrumentation. Astronomical symbols. Fancy Elixir stuff. Huh. Well, that's all pretty remarkable. Okay, so it is 11:56. I think we should wrap up so I can go help my sister in the garden. And I think actually there might be repair work on a water heater happening near me soon. That might get loud. So I think this would be a good time to cease and desist. I probably want to commit. Why don't I do that? See what the state of play is. Okay, so this is the top level README. Oh, I guess we just I never committed that. So add stub for how to get started to README. Boom. Yeah, we don't want that. That'd be bad. Oh, actually, is that still there? I thought we had moved that. Did it leave it? Or did I leave it in the wrong place? So there's images, GitHub, packages. No, I don't see it. I'm confused now. It was such a long thing, it didn't show me the images part. Okay. So this we sketched out. EC core, and that's also where this lived. So sketch README for EC core included a Excalidraw sketch, mostly by Eustace, of a basic evolutionary computation process. I don't want to look at that. That'd be bad. Actually, it's pretty interesting that that's like, viewable text, not necessarily understandable text, but it's viewable text. And I think that would do there. And well, I feel like, yeah, I mean, and this, it so badly needs to happen. The documentation is so bad otherwise, and that's not great. So, so sketch a README for EC linear, includes a diagram for 2-point crossover, similar diagrams. I've seen this with sim. What? Why is this not happy? Well, whatever. Diagrams for the other operators would also make sense. And one of the things that I would like to do. Oh, that was okay. Thank you. Good catch. One of the things I would like to do, I should push that, is actually make short videos of like, this is what 1-point crossover is, and this is what 2-point crossover is, and this is what uniform crossover is. And UMAD probably deserves its own video. Like some short little videos that like illustrate, and this is where Manim would be helpful. And yeah, so I'm thinking Manim instead of these diagrams, because it's nice to be able to like animate them. But same idea essentially. And I think that, you know, a set of short videos that like, you know, here are some key concepts and how they work would actually be really useful. And then we can link to them from our documentation. Woohoo! That'd be fun. Okay, so I have committed and I have pushed, and we should wrap up. Probably only one stream next week, because I will probably travel from Wisconsin to home one of those days. Yeah, so I think there could be a whole series of EC videos. And actually, yeah, you could like talk about things in the abstract and then be like, and here we have this framework, and look, it does the things. And that might be kind of fun, actually. So I'm guessing, I don't really know. We will have driven, but I may not do most of the driving. My sister might do most of the driving. I don't really know. We'll have driven quite a while on Friday, and I may not be very excited to drive on Saturday. On the other hand, and it could depend on the weather. Yeah, so I think I'll let folks know on Discord what's up. And we'll see what happens. And then at some point, it sounds to me like I really need to set up a time for a stream to do Manim stuff. Or take one of the weekend streams to do Manim. I don't know. We have figured this out. But if anybody has thoughts on when would be a good time to do Manim streams, you should talk about it on Discord. Otherwise, I'm going to see everybody later. Thank you very much. Goodbye. Find the right thing.